Okay, two more examples here. Here's example number 4. So we're looking for the volume of the solid whose base is bounded by x plus 2y equals 6, this line down here. So it's bounded by the points 0, 3, and 6, 0, and x equals 0 and y equals 0, the axis. And now it's perpendicular with respect to the y-axis. These are equilateral triangles perpendicular with respect to the y-axis going this way. So we're going to do it with respect to y. So don't forget our geometry from the isosceles triangles. Remember, if we have x, x, and x, therefore this will be x over 2. And so we have x, 2x, and x radical 3. So that's why we have radical 3 over 2 times x. Right there, if you remember from your geometry. So this is a 30-degree angle. That's a 60-degree angle. This will be 30, 60, 90. So that's how you get that. And therefore we have x is going to equal to 6 minus 2y. So we have the area is equal to 1/2. 1/2 base, this is the base. 1/2 base x, and then times the height, this height right here, which is what? Radical 3 over 2x. So if we take that all together, the area is equal to radical 3 over 4 x squared. And remember, x was equal to 6 minus 2y from manipulating this equation right here. So we take that and we integrate the area of that one slice over several slices. Okay, over the entire region. So I have radical 3 over 4 times the integral from 0 to 3 of 6 minus 2y squared dy. Again, we got that from down here. Just continuing it up. And so that's equal to radical 3 over 4, 0 to 3, and that's going to be what? We have to square that. We have to multiply that out. So we're going to get 4y squared minus 24y plus 36 dy. So all we did was just expand that out, multiply it out. Then now we can integrate. So it's radical 3 over 4, and it's going to be 4/3 y cubed minus 12y squared plus 36y. You evaluate that from 0 to 3, and you get radical 3 over 4 times, you put in those numbers, and you should get 36 minus 108 plus 108. And the zeros will obviously give you zeros. So you're going to get, it's going to be 9 radical 3. The zeros will give you zeros. You put in a 3 there, and you're going to get 27, 27 9, so 36. Yeah, that looks right. Alright, so in this last one here, we're looking for R is the region bounded by the curves y equals x squared, this parabola facing up, and then a downward facing parabola, y equals 2 minus x squared. And so it's this area in here that we're going to integrate to find the volume. Every cross section is perpendicular with respect to the y-axis, and the height is 3, so we know the height is equal to 3. And it says rectangles are rectangles. So therefore, we know that we're going to have area equal to base times height. What we have to be careful is when we do our base here, no problem, but when we do the height, well, we know the height's 3, but the base here is going to be with respect to one curve, and then we have another one, this one up here, that's going to be where it changes. See, it changes right here. It changes right there, so you're going to be talking about this curve right here, the downward facing parabola. So you're switching the curves. So you have to switch the functions. So we're going to get two separate areas and add them together. So base 1 on 0, 1, that's going to be x equals y, and the base 2 is going to be x equals 2 minus radical y. From solving these backwards, we solve them for x because we are doing it perpendicular with respect to the y-axis. So our first one there, area equals BH. So our first area, actually area 1 is equal to, oh, remember the height was given to be 3, so we know that's 3. And then, so I'm doing the bottom one first here. Okay, so this is area 1. I'm calling that one area 1, and I'm calling this one area 2. So that area 1 there is going to equal to this is radical y, so it's 2 radical y, 3 times 2 radical y, and that's going to be from 0 to 1. And the area 2, which is the top curve right here, where it's the bottom, it's the other curve. We're going to use we have x equals radical y, so x is equal to radical y. If we solve that out, x equals radical y, so we have 2 radical y. We did that one already. Oh, sorry, I take that one back. The other curve is, oh, sorry, x equals 2 minus radical y. Okay, so I already solved that one out, so it's 2 minus radical y. That's the, now we're using the bottom, we're using this one right here, the downward facing curve on the top. Okay, so this one right here. So therefore it's going to be 3, the same area, but it's going to be 2. Since there's obviously 2 of them, it's going to be 2 minus radical y and 2 minus radical, square root of 2 minus y, square root of 2 minus y, so it's 2 of them. So it's 3 times 2 times 3 times 2, the square root of 2 minus y, and that's from 1 to 2. So we have two separate parts that we have to put together. So this part here is down here because we have radical y twice, 2 radical y, and then up here we're using this curve, we have 2 minus radical y, and we double that. So we have 2 separate areas because we have 2 separate bases. So therefore this one's going to be, we're going to have 6, this is going to be 6 radical y from 0 to 1. So you go down here, see, this is going to be 6 radical y from 0 to 1, and this is going to be 1 to 2, and that's going to be 6 radical 2 minus y from 1 to 2. So if we go over here, now we integrate that area. We have the integral. So the volume is going to be from 0 to 1. The first volume from 0 to 1 is 6 radical y dy plus the integral from 1 to 2 of 6 radical 2 minus y dy, and that's going to equal to 6 times the integral of 0 to 1, and that's going to be, what do we have here? Oh, okay, we just read it out, clean it up, take the 6 out, plus the 6 times the integral from 1 to 2 of square root of 2 minus y dy, just read it out cleanly. So it's going to equal to 6 times 2/3 y to the 3/2, evaluated from 0 to 1, plus 6 times, this is going to be negative 2/3, because this is 1/2, right? This was the square root, that's 2/3. So that's going to be, oh, because of the negative 1, so be careful of that. That's going to be negative 2/3, okay? Because the 1/2 power, you have to be careful of that. Negative 2/3 times 2 minus y to the 3/2, evaluated from 1 to 2. So be careful of that right there. It's a negative right there. You see that one? Because when we do the 3/2, we divide by 3/2, which is really like multiplying. When we divide by 3/2, it's like multiplying by 2/3, but it becomes negative because of that chain rule there. And we're going from 1 to 2, so be careful of that. And then we evaluate that, so it's going to be 4. Well, 2/3 of 6 is 4. 4 times 1 minus 0 minus 4, again 4 here. Okay. Times, now you evaluate from 1 to 2, and it's going to be 0 minus 1. So you're going to be left with 4 plus 4. So our volume is going to equal 8. There you go.